Today we're going to talk about the concentration of solutions. We measure the concentration of solutions in something called molarity. Now I have two similar solutions here. Both of them have some amount of water in there. The stuff we dissolve something in is called the solvent. In this one, I've added some particles of solute. Solute is the stuff we dissolve into it. Over here, I'm also going to add particles of solute. Which one of these two containers is more concentrated? This one we would say is more concentrated because it has more solute and about the same amount of solvent. These two things together make the solution. How can I make this one less concentrated? I couldn't do it by adding more solute, and it'd be really difficult to take some solute out if you picture it as something like salt water. But I could add water to it if I wanted to spread those particles out some. So there are two things that go into measuring the concentration of a solution. This capital M signifies molarity. And those two things are the moles of solute and the liters of the solution. Whenever we calculate concentration, we're going to be using this formula, and we're going to be considering how many moles we have dissolved in how big of a volume. The units are typically called moles per liter or molar. Either one of those is acceptable. So let's take a look at our first sample problem here. We are going to find the concentration of a solution that is made by dissolving 30 grams of sodium hydroxide in 4,000 milliliters. Okay, so let's consider how we want to approach this. I'm looking for the molarity. If I want the molarity, I'm going to need to know the moles and the liters in order to calculate it. Do I know the moles? No, I don't. Do I have enough information to get the moles? Absolutely I do, because I know that we have 30 grams of sodium hydroxide, which is NaOH. So to get the moles, I can plug the grams into this formula. Grams equals moles times molecular weight. We will have 30 equals moles times the molecular weight, which is going to be 23 plus 16 plus 1, which is a total of 40. Now I'm going to divide both sides by 40, and we get 0.75 moles of NaOH. Now I'm almost there. I have the moles. Do I have the liters? I don't, but I'm really close. I was given the milliliters. Remember, you need to be able to convert the units from milliliters to liters. So when I convert 4,000 milliliters to liters, it'll be 4 liters. So the molarity will be equal to 0.75 divided by 4, which equals 0.1875 molar. The capital M is pronounced molar just like the tooth. And the units that you'll put on it is a capital M, or alternatively, one that's also acceptable is to do moles per liter. You're going to do a couple of practice problems that make use of these two formulas. Sometimes you'll be starting with the moles and ending with the grams. Sometimes you'll be starting with the grams and perhaps ending with the molarity.